Good morning, my dear students. So today in the sessions we are going to learn the sixth problem on the spring. First of all, I will read the questions. Calculate the wire diameter for a spring scale. The spring scale, it is given here 18 kilo Newton per meter. So the spring scale, or sometime is we can say as spring rate, it is represented by F0 equal to 18 kilo Newton per meter. Okay dear. Then the compressed to the 30 mm when coil is closed. Let us see if the some amount of compressive force is acting on the spring due to it causes deflection. So deflection, how much is that here? 30 mm. How much? 30 mm. The allowable shear stress is 345 mega Newton per meter square. So 345 as it is, mega means 10 power of how much dear? 6. 10 power of 6. Newton as it is, 1 meter equal to how much dear? I will present here. This is 345 mega means 10 power of how much? 6. Is it right? Newton as it is, okay dear, divided by, so 1 meter equal to how much dear? 1 meter equal to how much? 1000 mm. You know very well how much? 1000 mm. Here I am taking here 10 power of 3. Here the power is how much? So here meter square is there, so this means that you need to square this whole the value. Is it right? 10 power of 3 whole square, this is millimeter square. Okay, so 10 power of 3 to the 6, this 3 to the 6, 10 power of 6, and this is 10 power of 6 will be cancelled. The remaining term should be how much? 345 as it is, Newton divided by millimeter square. Because some students is having the dot here also. 18 as it is, kilo means how much dear? 10 power of 3. Okay, this is 10 power of how much? 10 power of 3. Newton as it is, 1 meter equal to how much dear? 1000 mm. This 10 power of 3 and this 10 power of 3 will be cancelled. The remaining should be how much? Only cancel means the remaining term should be Newton per millimeter square. How much dear? 18 Newton per millimeter square. As well as the spring index is given as how much? The spring index is given as 8 mm. The ends are square and ground. Also calculate the number of turns in the coils. We need to find out. The first of all, we need to find out the spring scale or stiffness in the spring. We need to find out. If you want to find out, then you have to refer the spring scale formula or spring rate formula. What is the formula is there? F0 spring rate equal to stiffness by 1. So you have to refer this equation from 11.7a, page number 170 from the Design Data Handbook by Mahadevan. So the spring scale, how much we know very well dear? The spring scale is how much? 18 Newton. Okay, deflection is how much dear? 30. 18 into 30 should be how much dear? 540 Newton. That is the value of force. Okay, after that, after the getting of the value of F, we need to find out the value of Wahl's factor. If you want to find out the value of Wahl's factor, then we know very well what is the equation of the Wahl's factor. K equal to 4 into spring index minus of 1 divided by 4 into spring index minus of 4 plus 0.615 divided by spring index. Refer the equation from the 11.2a page number 169. 4 into spring index is 8 minus of 1 divided by 4 into spring index 8 minus of 4 plus 0.615 divided by 8. If you divide the whole the value, then you will get the answer is Wahl's factor is 1.18. After that, we need to find out the diameter of the wire. This K value is Wahl's factor value. The diameter of the wire is the shear stress equal to 8 into force into spring index into Wahl's factor divided by pi into diameter of the coils. Refer the equation from 11.1d page number 169 from the design data handbook. The maximum allowable shear stress is given in the question is 345 Newton per mm square is given into 8 as it is. Force, how much we got here just now? 540. Since the spring index is 8, the Wahl's factor how much we got here? 1.18 divided by pi into d square. Just in this equation, you need to cross multiply these terms. D square as it is, the remaining term should be 8 into 540 into 8 into 1.18 divided by pi into 345. If you divide the whole the value, after that if you want to remove the square, it's make as root. Okay, root. Then if you substitute this value in the root, then you will get the value of diameter of the wire is 6.134 mm. The diameter of the wire how much here? How much we got here? 6.134 mm. After that, we need to find out how many number of the turns of a coil we need to find out in this problem. So for that reason, first of all, we need to assume the spring is made of cold drawn steel. Refer the table number 11.5 page number 190. So in this case, after that you will get the value D equal to how much? 6.3 mm. So I is indicate that I is the number of turns equal to Y is the deflection, G is indicate that modulus of rigidity of a material, and D is diameter of the coil divided by 8 into force into spring index. So Y how much we got here? 30 mm. So you have to refer this equation from the 11.6 page number 170 from the design data handbook. Y how much you got here? Y we got is 30. Modulus of rigidity you can easily get 0.0785 into the power of 6. D is how much here? 6.3 mm divided by 8 into F how much we got here? 540. Spring index C is how much? 8 cube. If you divide the whole the value with the help of calci, then you will get the answer is 6.77. So 6.77 tons should be approximately equal to the 7 tons we can assume. Okay, so next problem. I hope so no one is having doubt in this problem. Okay, the next problem is at the bottom of an elevator shaft, a group of identical springs are set in a parallel to absorb the shock of the elevator in case of a failure. The elevator weight. So in this case, the elevator weight, how much is given? The weight of the elevator is given as 28 kilonewton. 28 kilo means 10 power of 3 Newton. Assume that the elevator has a free fall of 1.2 meter from the rest. So this means that the free length is given as L0 is equal to 1.25 meter from the rest is given as. If you want to convert in millimeter, means 1.2 as it is 1 meter equal to how much? 1000 mm. Okay dear. Determine the maximum stress in each spring. So if each spring is made of 30 mm diameter rod, the diameter of this rod, or we can say as diameter of the wire, how much is given? D equal to 30 mm is given in this problem. For each spring, the spring index, how much is given here? The spring index is given as C equal to C, and the number of active turns is given as I equal to how much here? I equal to 15. Okay. So the number of active turns, how much is given here? The number of active turns I equal to is given as 15. Neglect any effect of the counterweight in the system, we have to neglect. Take the modulus of rigidity values already is given, how much? 83 giga Newton per meter square. So we know very well this 83 as it is, giga value is 10 power of 9. How much? 10 power of 9 Newton as it is. 1 meter equal to how much here? 1000 mm. Meter square nothing but 10 power of 6. This 10 power of here 10 power of 9, here 10 power of 6. This 10 power of 6 and this 10 power of 9 will be cancelled. The remaining how much will be there? 10 power of 3. Is it right? 83 as it is Newton per millimeter square. The first of all, what we to find out? We need to find out how much amount of force is acting on each spring. We need to find out how much amount of force is acting on each spring. Then how to find out? The force on the each spring equal to how much total force is acting on the spring divided by number of the turns, or we can say as number of spring. It is your wish. Total force, how much is that here? Total force is here, the weight of the elevator is 28 into 10 power of 3. Number of spin nothing but the number of turns. How much is there? 15. If you divide this whole the value, then you will get the answer is 3500 Newton you will get. After that, we need to find out how much amount of energy is absorbed by the spring. How much amount of energy absorbed by the spring equal to how much force is acting on the spring into total displacement. Into total displacement. The force on the spring is 3500. The force on each spring is 3500 into. So the free length is represented by LO plus Y nothing but deflection. 3500 into LO, how much? Free length, how much is there? 1.2 into 10 power of 3. If you multiply, then you will be get 1200 mm. Is it right? 1200 mm plus Y. So because we don't know the value of deflection, so that's what it is considered as equation number 1. After that, how much amount of energy is absorbed by the spring? So 1/2 force into deflection. We don't know the value of F, we don't know the value of Y, so that's what it is considered as equation number 2. So after that, we need to equate equation number 1 and equation number 2. Equation number 1 is how much is that here? 3500 into 1200 plus Y equal to 1/2 force into Y. Okay dear, 3500 as it is, 1200 plus Y equal to 1/2 force into Y. So after that, this 3500 just you need to multiply here. 3500 into 2, it should be how much? 7000. In bracket 1200 plus Y equal to force into Y. Okay na dear? 1200 plus Y, you need to divide here force into Y by 7000. After that, you need to separate this both numerator value. 1200 by denominator value is Y, 1200 by Y plus Y by Y equal to force by 7000. This y and y will cancel. The remaining should be how much? 1. 1200 by y plus 1 equal to f by 7000. This one, if it is moved toward this side, means it's make as a -1, because here positive sign. If this positive sign is moved toward right side, it is make as -1. This 1200 by y as it is equal to 4. Just you need to cross multiply here. 7000. Okay, 7000 by okay. Okay, f minus of 7000 by 7000. Okay dear, after that just you need to cross multiply here. 1200 into 7000 by cross here f minus of 7000. The remaining should be how much? Y. If you are multiplying the term 1200 into 7000, then you will get the value is 84 into 10 power 5. F minus of 7000. It is considered as equation number 3. Why? Because we don't know the value of f, we don't know the value of y. Because in this equation 2 is unknown value. If it is 2 is unknown value, we can't able to solve the problem. So that's what it is considered as equation number 3. After that, we need to find out how many number of the turns we need to find out. I is equal to number of the turns is equal to deflection into modulus of rigidity into d by 8 into force into spring index. Refer the equation from the 11.6 page number 170. Refer from the design data handbook by Mahadevan. Then I is number of the turns. How much is that here? 15 already is given. Is it right? Into y is how much? Y value already we solved. 84 into 10 power 5 by f minus of 7000. This is value of y only. The modulus of rigidity already is given in the question. How much? 83 into 10 power 3. This is the diameter. How much is given? 30 is given already. 8 as it is, f as it is, c is the spring index is given as 6 cube. After that, just you need to multiply this both the numerator value f minus of 7000 as well as 8 into 4 into 6 cube. You need to multiply, cross multiply toward left side. 15 into f minus of 7000 into 8 into f into 6000 equal to the above numerator value is 84 into 10 power of 5 into 83 into 10 power of 3 into 30. Just you need to multiply this term 15 into 8 into 6 cube, then you will get the answer is 25920 into f, then f minus of 7000 equal to, if you multiply this the whole the value, then you will get 20916 0 into 10 power of 9, you can say. After that you need to divide this whole the value, then you will get the value is 8069444.4. After that you need to multiply force into force, f square, f into f square minus as it is 7000 into f, 7000 f equal to 8069444.44. If it is moved toward here, it is make as minus equal to 0. So it is a form of ax square plus bx plus c equal to 0. So you have to follow the quadratic equations, otherwise you can solve with the help of calc. Okay, so a is 1, b is minus 7000, c is value is minus 8069444.44. Then you will get the maximum force value with the help of calc is 32121.57 Newton, or f equal to minus 25121.57 Newton you will get. After the getting the value, we need to find out the Wahl's factor. If you want to find out the Wahl's factor, the equation is k is equal to 4 into spring index minus of 1 divided by 4 into spring index minus 4 plus 0.615 divided by spring index. Refer the equation from 11.2a page number 169 from the design data handbook by Mahadevan. 4 into 6 minus of 1 divided by 4 into 6 minus of 4 plus 0.615 by spring index is 6. If you divide the value, then you will get the Wahl's factor value is 1.2525. After getting this value, your intention is you need to find out the maximum allowable shear stress we need to find out in this problem. If you want to find out the maximum allowable shear stress, tau equal to 8 into force into spring index into Wahl's factor divided by pi into diameter. 8 is, we know very well, force already we got it in the last year, F 32121.57, okay, into C is the spring index 6 into Wahl's factor is 1.2525 divided by pi into diameter of the coils, or number of, how much is given, diameter of the coil is given as 30, whole square will be there. If you divide the whole term with the help of calci, then you will get the answer is 683 Newton per mm square with the help of calci. So how much we got the maximum shear stress here? The maximum allowable shear stress we got as a 683 Newton per mm square. I hope so no one is having the doubt regarding up to here. If you have this small doubt regarding these sessions, please write down in the comment box, as well as please do the practice twice and thrice, then it should be very useful for the external examination point of view. Okay dear, thank you.